Polar coordinates part 2. This section deals with various forms of equations of a circle, various forms of equations of a conic, and some standard results of conics proved in polar coordinate system. Let us see the very basic equation of a circle. The polar equation of a circle of radius a and having center at the pole is given by r is equal to a. This theorem says the polar equation of a circle of radius a and having center at pole is given by r equal to a. So center of the circle p r comma theta, let it be any variable point on the circle. By equation of circle we mean the mathematical equation in terms of r and theta which each and every point on the circle obeys. Now if you see, each and every point on the circle is at a distance of a units from pole. So irrespective of the position of the point on the circle, r will be equal to a. We can say equation of the circle is r equal to a. This we can present it this way. Let O be the pole, Ox be the initial line, and p r comma theta be any variable point on the circle. Then r equal to OP, which is equal to a. Conversely, if p r comma theta is a point such that r equal to a, then p lies in the circle. So both the statements together conclude that the polar equation of the circle is r is equal to a. Next, the polar equation of the circle of radius a and having center c comma alpha is r square minus 2cr cos theta minus alpha equal to a square minus c square. The polar equation of the circle of radius a and center at c comma alpha is given by r square minus 2cr cos theta minus alpha equal to a square minus c square. Let us prove this. Let p r comma theta be any variable point on the circle. C comma alpha is given to be the center. So OC will be C, OP is R, and angle POC will be theta minus alpha. C being the center of the circle and P any point on the circle, distance CP is radius of the circle. So if we observe the triangle OCP, we know PC radius A, OP is R, OC is C, and angle POC is theta minus alpha. Now in the triangle POC, because we know all three sides and one angle, applying cosine rule, CP square is equal to OP square plus OC square minus 2OP OC cos angle POC. So CP square is A square, radius of the circle, equal to R square plus C square minus 2RC cos theta minus alpha. Segregating the terms, R square minus 2RC cos theta minus alpha equal to A square minus C square. Therefore we can say locus of point P is R square minus 2RC cos theta minus alpha equal to A square minus C square, or the polar equation of the circle is R square minus 2RC cos theta minus alpha equal to A square minus C square. We have to remember this equation, and also we need to correlate with the positions. C is distance of center from the pole, alpha is inclination of OC with initial ray, A is radius of the circle, and C is again distance of the center from origin. A small note: if alpha is the vectorial angle of the center and circle is passing through the pole with radius a, then equation of the circle is given as r is equal to 2a cos theta minus alpha. This can be proved either by substituting pole in the equation or even with simple perpendicularity. The polar equation of a circle of radius a passing through the pole and its diameter as initial line. Additionally, if diameter is initial line, alpha will be equal to 0. So the equation r equal to 2a cos theta minus alpha reduces to r equal to 2a cos theta. Of the circle of radius a and touching the initial radius a, line joining center to the pole is perpendicular to initial ray. Hence you can say alpha is pi by 2, or the equation is r is equal to 2a sin theta. So one important thing what you have to remember in this theorem is r square minus 2cr cos theta minus alpha equal to a square minus c square is general equation of the circle. Again, given diametric ends of circle r1 theta 1 and r2 theta 2, let us see how to find equation of circle. Let us say p r comma theta be any variable point on the circle. AB is diameter, so angle APB will be 90 degrees. Angle in a semicircle is 90 degrees. And once we know that this is 90 degrees, APB is a right angle triangle, so we can apply Pythagoras theorem. AP square plus PB square is equal to AB square. AP square, A is r1 comma theta, A is r1 comma theta 1, B is r2 comma theta 2, A is known, P is known. AP square can be calculated by distance formula r square plus r1 square minus 2r r1 cos theta minus theta 1. Similarly, BP square is r square plus r2 square minus 2r r2 cos theta minus theta 2. And AB square is r1 square plus r2 square minus 2r1 r2 cos theta 1 minus theta 2. Substituting them in one, r square plus r1 square minus 2r r1 cos theta minus theta 1 plus BP square, that is r square plus r2 square minus 2r r2 cos theta minus theta 2 is equal to AB square, and AB square is r1 square plus r2 square minus 2r1 r2 cos theta 1 minus theta 2. We can see r1 square getting cancelled, r2 square getting cancelled on both sides, and segregating all the terms, we have equation of the required circle as r square minus r into cos theta minus theta 1 plus cos theta minus theta 2 plus r1 r2 cos theta 1 minus theta 2 is equal to 0. So whenever you are given diametric ends, this is the process in which we find equation of the circle. Let us look at some questions. We have to find polar equation of the circle with its center at 4 comma pi by 6 and radius 5 units. We have to find equation of circle with center at 4 comma pi by 6 and radius 5 units. C is given to be 4, alpha is given to be pi by 6, and radius A is given to be 5 units. And in the previous theorem we discussed equation of circle with center C comma alpha and radius A is given by r square minus 2cr cos theta minus alpha is equal to a square minus c square. So simply we have to substitute these values in this equation. Alpha is pi by 6, c is 4 and a is 5. So the equation of the circle is r square minus 8r cos theta minus pi by 6 minus 9 is equal to 0. Next, let us find the polar equation of the circle whose endpoints of the diameter are given. So, given endpoints of the diameter, let P r comma theta be any variable point on the circle. Angle APB is 90 degrees. So, we can apply Pythagoras theorem. AP square plus PB square is equal to AB square. Using distance formula, A is root 2 comma pi by 4. So, AP square will be r square plus root 2 square minus 2r root 2 cos theta minus pi by 4. Similarly, we can find BP square and AB square, and substituting in equation number 1, r square plus 2 minus 2 root 2 r cos theta minus pi by 4 plus r square plus 2 minus 2 root 2 r cos theta minus 3 pi by 4 is equal to AB square, which is 4. Simplifying, two plus 2, 4 gets cancelled. R square makes it 2r square minus 2 root minus pi by 4 plus cos theta minus 3 pi by 4 is equal to 0. R gets cancelled, root 2 gets cancelled. We have a simple equation, r is equal to 2 sin theta. So hence the required circle equation is r equal to 2 sin theta. Next example, find center and radius of the circle r square minus 2r into 3 cos theta plus 4 sin theta equal to 39. Equation of the circle r square minus 2r into 3 cos theta plus 4 sin theta equal to 39 resembles r square minus 2cr cos theta minus alpha equal to a square minus by under root 3 square plus 4 square, which is, and also multiply. So we have r square minus 2r into 5, 3 by 5 cos theta plus 4 by 5 sin theta equal to 39. If 3 by 5 we call some cos alpha and 4 by 5 some sin alpha, we have r square minus 10r cos theta minus alpha equal to 39, where tan alpha is 4 by 3. Now we can see in place of c we have 5, in place of a square minus c square we have 39. So c should be equal to 5, alpha is tan inverse 4 by 3, and a square minus c square is 39. So a square is 39 plus 25, 64, or a is 8. Hence center of the circle is 5 comma tan inverse 4 by 3 and radius 8 units. Next, let us discuss polar equation of a conic in its standard form. The polar equation of a conic in its standard form is given by L by R is equal to 1 plus e cos theta. L by R equal to 1 plus e cos theta. Let us prove this. We know definition of a conic. It is locus of a point P such that the ratio PS divided by PM, distance from focus if S is the focus, and PM if it is perpendicular distance on directrix, PS by PM will be a constant called eccentricity. So let S be the focus and Z be the projection of S on the directrix. This line is directrix. S we are calling it focus, and focus we are assuming it as pole, and SZ, that is axis of the conic, we are calling it the initial line. SL is a line perpendicular to the axis and passing through focus. So SL is nothing but semi-lattice rectum. And if we assume eccentricity to be E, drop a perpendicular from L to the directrix. Let the projection be K. L lies on the conic, so it satisfies the conic property. Ls divided by Lk, distance from focus by distance from directrix, will be equal to eccentricity. Ls we already know, it is L, so Lk will be equal to L by E, and Lk in dimensions is same as Sz. So Ls is E into Lk, Lk is same as Sz, or Sz we can say is equal to L by E. Now let us assume any point on the curve Pr comma theta be any point on the conic. M be the projection of P. From P I am dropping perpendicular onto the directrix, and let this point be M, and N be the projection of P on Sz. N be the projection of P on Sz. P being a point on the conic, Ps divided by Pm will be equal to eccentricity. Now Ps is already R, known quantity, and if we find Pm, we can find equation of the conic. Pm will be same as Nz, and Nz will be Sz minus Sn. Sz we found out L by E. Sn from this triangle Psn is r cos theta. So we can say Pm is equal to Sz minus Sp cos theta, or we have equation to be r equal to E into Sz is L by E and Sp is r, so E into L by E minus r cos theta. Collecting all the terms together, r is equal to L minus Er cos theta, or r plus Re cos theta is equal to L. Taking r common and dividing one by the other, we have L by R is equal to 1 plus E cos theta. So we can say equation of the conic is L by R is equal to 1 plus E cos theta. Let us look at the theorem again in brief. We are assuming S focus to be pole and axis to be initial ray. Length of semi-lattice rectum L is given to us. From L we are dropping a projection. Ls by Lk is equal to E. So Lk is equal to L by E. Lk is same as Sz. So Sz is L by E. And P is any point on the conic r comma theta. Sp is r. Pm is equal to Nz, which is equal to Sz minus Sn, that is L by E minus r cos theta. So we can say R Sp is equal to E into L by E minus r cos theta, or simply L minus Er cos theta. Segregating all the terms on one side, R plus Re cos theta is equal to L, or taking R common, L by R is equal to 1 plus E cos theta. So equation of conic we can say is L by R is equal to 1 plus E cos theta, where L is length of semi-lattice rectum and E the eccentricity. This equation we have to remember because all other questions will be based on this. Now initial ray we assumed as Sz. Alternately, if we assume Zs as the initial line, then there will be a sign change. Equation of the conic will become L by R is equal to 1 minus e cos theta. Or if the conic is directed this way instead of this way, if it is directed this way, then again conic equation will come out to be L by R is equal to 1 minus e cos theta. The polar equation of the parabola, obviously eccentricity for parabola is 1, so E we are replacing it by 1. Equation will be L by R is equal to 1 plus cos theta, or L by R is equal to 2 cos square theta by 2. Next, we have polar equation of a parabola having lattice rectum 4a. If lattice rectum is 4a, semi-lattice rectum will be 2a. Replace L by 2a. Equation of directrix of the conic L by R is equal to 1 plus e cos theta is L by R is equal to e cos theta. Let us prove this. Let Z be the foot of the perpendicular from S on the directrix. So Sz, like in the previous proof we discussed, is equal to L by E. Q r comma theta be any point on the directrix of the conic. From the right angle triangle, Sz will be equal to Sq cos theta, or L by E is equal to R cos theta, or L by R is equal to E cos theta, which will be equation of the directrix of the conic. Let us solve some questions. In a parabola, prove that length of a focal chord which is included at pi by 6 let us solve some examples. In a parabola, prove that the length of a focal chord which is inclined at an angle pi by 6 to the axis is 4 times the length of the lattice rectum. So we have to talk of some property of a parabola which is having a focal chord in particular direction, and we have to prove that the length of this particular focal chord will be 4 times the length of the lattice rectum. We know equation of any conic in its standard form is L by R is equal to 1 plus e cos theta, and for parabola E is equal to 1. So there is a focal chord PSP dash. It is inclined at an angle of pi by 6 with the initial ray. We have to talk of length of this chord. So length of the chord PP dash is nothing but PS plus SP dash. PS plus SP dash. Coordinates of the point P will be SP comma pi by 6. Coordinates of point P will be S if it is pole, SP comma pi by 6, and coordinates of P dash will be length SP dash comma pi by 6 plus pi, that is 7 pi by 6. So P will be SP comma pi by 6 and P dash will be SP dash comma 7 pi by 6. Now P satisfies parabola equation. Substituting P, we have L by SP is equal to 1 plus cos 30. In place of theta we are substituting 30, and in place of R we are substituting SP. So L by SP is equal to 2 plus root 3 by 2, or SP is equal to 2L by 2 plus root 3. So we are now able to find length of one portion of the focal chord in terms of semi-lattice rectum. Similarly, P dash is also a point on the curve. So substituting L by SP dash is equal to 1 plus cos 7 pi by 6, that is 210 degrees. Or SP dash we have it equal to 2L by 2 minus root 3. There is only one change from 2 plus root 3 to 2 minus root 3. So we are interested in PP dash, the length of the focal chord, which is SP plus SP dash, or adding the two terms. In the cross multiplication, minus root 3 plus root 3 gets cancelled. In the denominator we have a plus b into a minus b formula. So on simplification we get PP dash equal to 8L, which is nothing but 4 times of 2L or 4 times of latter sector. So using the condition that P is a point on the curve, we are getting SP, and also P dash is a point on the curve, we are getting SP dash, and adding the two we are getting the length of the focal chord, which is 4 times the latter sector. Next example, if PP dash and QQ dash are the perpendicular focal chords of a conic, then we have to prove that 1 by SP into SP dash plus 1 by SQ into SQ dash is a constant. If PP dash and QQ dash are perpendicular focal chords of any conic, then we have to prove that 1 by SP into SP dash plus 1 by SQ into SQ dash is a constant. We know that equation of any conic in its standard form is L by R is equal to 1 plus E cos theta, and it is also given that PP dash and QQ dash are two perpendicular focal chords. They pass through focus and they are perpendicular to one another. Let us assume SP is inclined at an angle theta with the initial ray. So coordinates of point P will be SP comma theta, and coordinates of the point Q will be SQ comma theta plus 90. Coordinates of point P dash will be SP dash comma theta plus 180, and coordinates of point Q dash will be SQ dash comma 270 plus theta. Now we have coordinates of all the 4 points in terms of theta and their distances from focus. So let SP comma theta be point P, where S is the focus, and P satisfies the curve equation. So L by SP will be equal to 1 plus E cos theta, or 1 by SP is equal to 1 plus E cos theta by L. Similarly, since PP dash is focal chord is collinear with S, P dash coordinates will be SP dash comma theta plus 180. P dash is also a point on the curve, so substituting L by SP dash is equal to 1 plus E cos 180 plus theta, which is in turn equal to 1 minus E cos theta. So 1 by SP dash will be 1 minus E cos theta divided by L. Similarly, we can find SQ dash and SQ. Q dash is a point SQ dash comma 3 pi by 2 plus theta. Substituting in the curve equation, we have L by SQ dash is equal to 1 plus E cos 3 pi by 2 plus theta, or 1 by SQ dash we have 1 plus E sin theta divided by L. Similarly, 1 by SQ will be 1 minus E sin theta divided by L. What we are interested in is 1 by SP into SP dash plus 1 by SQ into SQ dash. So substituting all the obtained results in this 1 by SP into SP dash plus 1 by SQ into SQ dash, we have 1 plus E cos theta by L into 1 minus E cos theta by L plus 1 minus E sin theta by L into 1 plus E sin theta by L, which is equal to 2 minus E square by L square, which is independent of theta. So hence we have proved that it is a constant. The thought process remains same for all these questions. Next one, we have to prove that Perpendicular focal chords of a rectangular hyperbola are of equal length. So again we are talking of two perpendicular focal chords, but for a particular case of rectangular hyperbola, and we have to prove it they are of equal length. Equation of rectangular hyperbola in its standard form would be L by R is equal to 1 plus root 2 cos theta. Eccentricity is root 2 for a rectangular hyperbola. PP dash and QQ dash, let they be the perpendicular focal chords. So if we assume SP is inclined at an angle of alpha with x-axis, SQ will be inclined at an angle of 90 plus alpha, SP dash at an angle of 180 plus alpha, and Q dash will be inclined at an angle of 270 plus alpha. We can write the coordinates. If P is SP comma alpha, then P dash is SP dash comma 180 plus alpha, Q is SQ comma alpha plus 90, and Q dash is SQ dash comma 270 plus alpha. Since P and P dash are points on rectangular hyperbola, L by SP will be equal to 1 plus root 2 cos alpha, that is P satisfies the curve equation, or 1 by SP will be equal to 1 plus root 2 cos alpha by L. SP we have it equal to L by 1 plus root 2 cos alpha. Similarly we can find out SP dash. L by SP dash will be equal to 1 plus root 2 cos 180 plus alpha. SP dash comma 180 plus alpha is a point on the curve L by R equal to 1 plus root 2 cos theta. So substituting we get SP dash is equal to L by 1 minus root 2 cos alpha. Now chord length PP dash will be SP plus SP dash, which is L by 1 plus root 2 cos alpha plus 1 by L by 1 minus root 2 cos alpha. So on simplification we get PP dash to be minus 2L by cos 2 alpha. Similarly we have to find QQ dash, and our target is to prove these two chords are of equal length, that is PP dash is equal to QQ dash. So to find QQ dash, let us first find SQ and then SQ dash. Q is SQ comma 90 plus alpha. It is a point on the rectangular hyperbola, so L by SQ will be equal to 1 plus root 2 cos 90 plus alpha. So SQ is L by 1 minus root 2 sin alpha. Similarly SQ dash we can find, in place of 90 plus alpha you will have 270 plus alpha, so only difference will be the sign here. SQ dash will be equal to L by 1 plus root 2 sin alpha. So we are interested in finding length of the chord QQ dash, and QQ dash will be equal to SQ plus SQ dash. QQ dash will be equal to SQ plus SQ dash. Summing them and simplifying, root 2 sin alpha minus root 2 sin alpha gets cancelled. Denominator we can see a minus b into a plus b formula. So QQ dash is equal to 2L by cos 2 alpha. From 1 and 2, PP dash we got it to be 2L by cos 2 alpha, and QQ dash also we got it to be 2L by cos 2 alpha. We can say PP dash is equal to QQ dash. PP dash is equal to QQ dash, and that is what we are supposed to prove. Next question. If PSQ is a chord passing through focus S of a conic and L is the semilattice rectum, then we have to prove 1 by SP plus 1 by SQ is equal to 2 by L. Again, let equation of the conic in its standard form be L by R is equal to 1 plus E cos theta. PSQ is some focal chord. Let SP has inclination alpha, SQ will be having inclination pi plus alpha. Coordinates of P would be SP comma alpha and coordinates of Q would be SQ comma pi plus alpha. So if SP comma alpha be any point on the conic, substituting in the conic equation we have L by SP is equal to 1 plus E cos alpha, or 1 by SP is equal to 1 plus E cos theta by L. Q coordinates are SQ comma 180 plus theta, 180 plus alpha. This is other end of the focal chord. This is also a point on the conic, so it satisfies 1 by SQ is equal to 1 plus E cos 180 plus alpha, which is equal to 1 minus E cos alpha. So 1 by SQ will be 1 minus E cos alpha by L. Adding 1 and 2, we have 1 by SP plus 1 by SQ is equal to 1 plus E cos alpha by L plus 1 minus E cos alpha by L. E cos alpha gets cancelled, we have 2 by L. Next question. PP dash and QQ dash are perpendicular focal chords of a conic. We have to show that 1 by PP dash plus 1 by QQ dash is equal to A. Process is similar. PP dash and QQ dash are perpendicular focal chords of the conic whose equation is L by R is equal to 1 plus E cos theta. We will find SP, we will find SP dash, SQ, SQ dash. SP plus SP dash will give us PP dash. SQ plus SQ dash will give us QQ dash. So the coordinates of all these points are P SP comma alpha, P dash SP dash comma 180 plus alpha, Q SQ comma 90 plus alpha, and Q dash SQ dash comma 90 plus 270 plus alpha. SP will be like in previous questions, L by 1 plus E cos alpha, and SP dash will be L by 1 minus E cos alpha. Adding, similarly we have SQ is equal to L by 1 minus E sin alpha and SQ dash equal to L by 1 minus E sin alpha. Adding, PP dash is equal to 2L by 1 minus E square cos square alpha, and QQ dash is equal to 2L by 1 minus E square sin square alpha. What we have to prove is 1 by PP dash plus 1 by QQ dash. This sum we can see it is 2 minus E square by 2L, which is independent of alpha, hence is a constant.